Hello my dear students, I am Divyam and I am welcoming you all in my another video. In this video we are going to discuss about how you can write IUPAC nomenclature of given coordination compound. So firstly you have to remember that coordination compound consists of coordination sphere, and that sphere can be anionic, cationic, neutral, or consist of both anionic and cationic. So you have to remember that you firstly identify the given coordination sphere in this category. Okay, this is your first rule, that cation named firstly and then the anion. So you first have to identify the cation and anion, and you have to name cation firstly. Second rule is that ligands are named first and then central metal atom. As you know that if it's a coordination sphere, this is what? This is ligand. This is central atom. Okay, metal atom. So ligands are named first and then central metal atom. The third rule is that naming of ligands. Naming of ligand is very important, and for that you have to learn a chart which I am showing you right now. See, there are different types of ligand: negative ligands, neutral ligands, okay, and some positive ligands are also there, but in your course only negative and neutral ligands you have to remember. Okay, so the ligands are monodentate and bidentate. So third rule is that naming of ligand. So in naming of ligand you have to learn the name of these ligands. See, SO4 2 negative, we write it as sulfate 2. Negative ligands end with an O. It's a sulfate, but we have to write it sulfato. It's a hydride, but we have to write hydrido. It's a cyno, okay. NCS negative is isothiocyanate. As in general we call it as isothiocyanate, but in coordination chemistry we name it as isothiocyanate. CO32 negative carbonato, NO2 negative nitrito. If it's right like this, it's nitrito N, and if I write it ONO negative, it will call it as nitrito O. Okay, NC negative is isocyano and CN negative is cyano. Okay? CH3CO negative is acetato, O2 negative oxo, ONO negative nitrito O, as we has already discussed, SCN negative thiocyanato, and NCS negative is isothiocyanate. Okay, X negative is halido, OH negative is hydroxo. Okay, some are bidentate ligands also. Oxalato, which is abbreviated as OX, and glycinato, we abbreviate it as GLY. Okay, the formula is this. So naming of ligand consists of these learning part. Okay, and also if the ligand is neutral, are named as it is. Let's say if it's CH3NH2 methenamine C5H5N, it's named as it is pyridine. Okay, if it's a bidentate ligand like ethane 1,2-diamine, you have to learn this structure. It's very important and abbreviated as EN. Okay, some of the neutral ligands have been changed. Some of the names which has been changed in coordination chemistry, those are H2O, we call it as aqua, NH3 having double M here, CO carbonyl, and NO nitrocell. So we will consider this chart, okay, by writing the name of given coordination compounds. Okay, fine. The next rule is more than one type of ligand named alphabetically. If we have more than one type of ligands, let's say, for example, NiNH3 whole 4Cl2. In this coordination compound, we have two different types of ligands. So we will write it according to their alphabetical order. Okay. So this is amine. Just like NH3 is amine and Cl is chloride. So A will come first and then chloride. The next rule is multiplying prefixes. It means that if we have 4 NH3 here, so we will write tetra. If we have 2 chloride here, we will write what? Di. Okay. So multiplying prefixes. The sixth rule is naming central metal atom. So this naming of central metal atom is dependent on this anionic, cationic and neutral, because this identification play an important role in naming the central metal atom. Okay, we will discuss this later. And the last but not the least, the last rule is oxidation number written in Roman number. The oxidation number of oxidation number of central metal atom is written in Roman number. Okay, so this is the there are 7 rules for naming the coordination compounds. Okay, so let's start with a given example. First of all, let's say we have to write the name of this particular compound. Okay, we have to name this. So how we are going to start? We are going to start by the identification of sphere, coordination sphere. So the coordination sphere is what? Is this a negatively charged or positively charged? Yes. Very good. Because if it dissociate, it forms 4K plus and FeCN6 power 4 negative. Okay, so here you can see the cation is this, and if we see the rule number 1, cation named firstly and then anion. So we have to write the name of this potassium first and then the name of coordination sphere. So first of all we have to write what? We have to write potassium. Okay, now we have to write the name of ligand. So the name of ligand here is Cn, and the name Cn, how we write it? We write it as cyano. Okay, cyano, and there are 6, so hexacyano. Okay, and now for iron, we have to write ferrate, because for negatively charged coordination sphere we end the central metal atom with 8. Okay, so we will write here ferrate. And what is the coordination, what is the oxidation number of central metal atom here? We have to calculate it, because this cyano is negatively charged ligand, it bears a negative sign here. So for multiply a single negative charge, it's because Cn is monodentate bearing a single negative charge. So here the total charge is 6 negative. So if we multiply it with 4 negative, what comes? 2. So we will write here 2. Okay, if you have to calculate the oxidation number of central metal atom, we write it at like this: plus minus 1 multiplied by 6 is equals to minus 4. Here it comes and x is equals to -4 plus 6. Now x is 2. Okay, so here we are writing the oxidation number as 2. So the name is potassium hexacyanoferrate 2. Is this clear? Let us say if we have this type of coordination compound and we have to write. So here is only one part, that is an ionic part. So how we will start it? We will start this with rule number 2. First we will write the name of ligand by using its prefix. Prefix is hexacyanoferrate 2. Am I clear? And for this hexa, for NH3 is a neutral ligand, and we write amine. So the name will amine nickel, and it's a neutral, so it will come as this 2. Okay, and for this is tetra for 4. CO is again a neutral ligand, name as carbonyl. So tetra carbonyl nickel. Okay, 0. So hope this is clear. Okay, the last example is we can write, we have 2 different types of ligands here. So let's start the writing. Again, if we go by alphabetical order, amine will be named first. So tetra amine dichloride do, because Cl is a negative ligand and we have to end negative ligand with O. So dichlorido nickel, and you have to calculate the oxidation number. So for that you can calculate it as amine is positively neutral. So x 0 multiplied by 4 plus 2 multiplied by -1, because chlorine having what? Chlorine is having -1 charge here. So x plus -2 is equals to 0. X is equals to 2. Okay, so the oxidation state of central metal atom will be 2. So we will write it in Roman number. Okay, hope this topic is clear. So thank you for watching. If you like my video, please share, subscribe and like, and also press the bell icon so that you can get my updates very quickly. And thank you for watching once again.